All right, so let's talk about how to model inheritance. Again, inheritance is a very common concept in object-oriented programming. We use it every day. It's a very useful way to break large applications into self-contained modular classes that can then build on each other, right, by inheriting from one another. But that feature, that concept, is entirely lacking in a relational database, right? And we already hinted at several strategies that we could use to model such a concept in a relational database. And so let's cover it and see how JPA simplifies or helps us to implement this kind of concept. So there are at least three different strategies that we can use to implement inheritance or specialization in a relational database. The three strategies are named joined, single table, and table per class. Join is AKA denormalize. Single table, normalized. Oh, I'm sorry, I have it backwards. Normalized. I guess AKA is too long. Normalized. So yeah, joined, AKA normalized, denormalized, and the table per class. The table per class, we'll see that the normalized and the denormalized have some problems. Okay, they have pros and cons, both of them. And what the table per class tries to do is bridge those two to have the best of both worlds. Right? So let's take a look at the joined or normalized strategy. Right? So the normalized strategy, as the name suggests, so first let's look at this example. So we have a student that submits a quiz, and these are the answers that the student submits. But the quiz has any number of questions. And each question can be of different types. It could be a true-false question. It could be a fill-in-the-blanks. It could be a multiple-choice questions. So to implement, typically, what you would do in a simple, using just plain old object-oriented technology, you would have a base class, right? That captures all the properties that are common to all the other classes. In this case, here we have a base question. I'm following a naming convention that keeps track of the strategy that I'm going to use. Right, so in this case, we're going to use the joined strategy. So I named my base class. I called it base question joined. All right, base. So just to remind in my head that this is the base class. Typically, this would be just called question, and that's it, right? If this were not an academic example, it would just be called question, and that's it. All right, so it has all the fields that are common to all questions. All questions have IDs. They all have how many points the question is, the title of the question, maybe descriptions, instructions on how to answer the question. Okay. Also, notice that we have a couple more annotations here. We have entity. Obviously, it's an entity. It's going to be mapped to a table. We also have here an additional annotation called @table. So @table overrides the default name of the table. Right? By default, the table would be called base_question_joined. Right? That would be the default name of the table. It's based off of the name of the class. But you can override that and say, no, don't guess at the name of the table. I will explicitly tell you what I want the table to be called. And we do that by using the table annotation. So table, the name of the table, I want to be called joined base question. Everyone okay? The other annotation that we're adding here is inheritance. And we're saying that there are going to be several other classes that are going to inherit from this class. They were going to extend this class. And we're configuring here what strategy we want to use. Do we want to use one table and use a D type? That's a default. The default is to use the denormalized implementation. Right? That's the default. Here we're overriding it. It says no, don't use the default strategy. Instead, use this other strategy called the joined strategy. Okay? What that's going to do is going to generate for each class is going to generate a dedicated table, right? Which is perhaps the most intuitive implementation. You see one table, one class. You would expect that there's also one table. You have one class, one table, one class, one table. Yes? Right? So this is perhaps the most intuitive, to map the two different worlds. Then we have another derived class called the true or false question joined. Right? This is to be able to capture. This is a specialization of the more generic question. The generic question has how many points, the title, description, instructions. This was inheriting from that, extending the base question joined, but it's adding to it an additional field, whether the question is true or false, right? Whether the right answer is true or false. Make sense? Right. A couple things here to note. We are overriding the default name of the table. The default name of the table would be true underscore or underscore false underscore question underscore joined. That would be the default name of the table, right? Again, based on the name of the class. But instead, I am overriding it, and I'm using this name instead. Yes?
On the previous slide, the inheritance annotation, so do you only declare that
on the base? Yeah, you only declare at the root of the inheritance chain. Right? So this is presumably the root, right? And then everybody else inherits from here. Yep. So the chain is followed by the extents. Right? So you can follow the extents chain all the way down. Right? Another thing that I'm pointing out here is that you can override the name of the column. Right? The default name of the column is based on the name of the field. Right, the name of the field here is true. The name of the field generated in the database would be is underscore true, all lowercase. Here I'm generating the name in uppercase. I'm saying that I want the name of the field to be is underscore true, but all uppercase, not lowercase. Okay? I also can configure whether this is a required field. Right? I have to know whether this answer is true or false. So I'm turning on nullable false, right? So that's gonna add a not null to the field in the relational database. Make sense? Okay. Fill in the blanks is similar, right? We're extending from the same base question joined. Where the specialization here is that we have variables, right? Presumably in a fill in the blanks, I'll have multiple blanks that I need to fill in. I need to know, well, each one has to have a label, and it has to have a valid value associated with it. So variables presumably is a comma-separated a tuple, right, of name-value pairs. Okay, doesn't matter. It's a string, just a string. Notice that I've overwritten the name of the table, overwritten the name of the variables. All right, so this is what gets generated. We have what gets generated is the joined base question for the base class, right? With the fields ID, description, instructions, points, and title, right? And declare the primary key. Right? Notice that there's no D type. See that? There's no D type. For the other tables, we have the other tables that we have. Those are the names we gave them. And the fields that were added, the IDs and the variables. I was expecting this to have a foreign key. Let me see. Did it not generate a foreign key? Let's play around with it. Let's actually play around with it. Let's see. Let's create in our model. let's create a new class. And we'll put it in a separate package so that we can keep track of this. So it'll be inheritance, inheritance, and we'll do joined first. Oh, and this will be, what's the name? Base question joined. Finish. And I'll just copy this. We'll load entity, table, inheritance, persistence, and we'll remove this ellipses, and we'll generate the setters and getters. Okay, and we can create the other couple of classes. This will be true or false joined, and we'll create it in the same place, new class. Oops. Entity table. All right, very good. And we'll have to generate the setters and getters. And finally, we'll implement fill in the blanks joined. A new class here. And we'll copy this. Table, column, very good. And we can generate the setters and getters. All right, let's, if we run this, let's stop this. Hopefully it'll generate the fields, or probably fail on that section that we had earlier, but hopefully it'll implement these. Oh, this takes forever, doesn't it? Come on. All right, while that's doing its thing, let's go back. What it generates is it's three tables, right? And these three tables are meant to work together, so that when you insert into a new instance of a joined true or false, it'll insert in two tables. It'll insert here, and it'll insert in the base table as well, right? Because these are meant to coexist, right? These two records are meant to coexist, and when you instantiate the object, you need to be able to join these two, right? Read from both tables, and then to populate the new instance. And that's what's annoying, right? That you have to join two tables, and it gets even more annoying when you have your inheritance chain is very deep, right? You have classes that inherit from other classes, from other classes, from other classes, right? So if you need to instantiate an instance of something that is way down in the leaf of a very deep branch in your inheritance tree, right? You're going to have to join, 4, 5, 6 tables, all of them in the inheritance chain. So this strategy is seldom used. Instead, we would use either a join, a denormalized implementation, or a single multiple table per class implementation. Here we created all the CRUDs. Let's see if this worked. Let's see if we generated the tables. There we go. So here they are. Let's do the base question. So send. There's our base question, and here's the fill in the blank. Oh, there's the foreign key. I must have forgotten to copy it. So here's the primary key for the ID, and it's also a foreign key that references the base class. Yes?
Can we configure the constraint name of the foreign key in Java?
Yes, you can. Yep, the constraint. Otherwise, it'll be just random. Yeah, it's random. Yep. And same thing for the other one. Yeah, excellent, right? So that's exactly what we were expecting. I must have forgotten the foreign key when I copied this. So yeah, so to use these, you would have dedicated repositories for each one of these, right? So you would implement all these interfaces so that you can instantiate them independently from one another. So in the repositories, we can create a new repository class, actually, and this would be repositories, inheritance, joined. And we'll start with the base repository. Each one has to have its own repository. Finish. Oh, it's not actually a class, right? It's an interface that I think I already have here. There we go. And for each one of these, right? Once we have them, we can then instantiate them independently. This is from a REST controller, but this could also be a test. This could be a test. So test joined. So this could be perhaps a test create base question, which here it's instantiating a base question. Or it's instantiating a create fill in the blank. So this is a test. Doesn't return anything. No, it doesn't return anything. Just saves. We haven't looked at services just yet. So this is getting a little bit ahead of itself. So this doesn't return anything, so it's void, and this is void too. And so this creates each one of them, right? So void, test, create, and then saves. So notice that this instantiates the base question. This one instantiates the fill in the blank question and saves them. And they're inserted. So some of the fields are stored in the base records, right? And some of them are stored in the other tables. That means when you retrieve them, they're going to have to be joined from both places, right? Okay, so for instance, after inserting them, notice that the three questions that we added. The first one was a base question, meaning it only had a description, instructions, points, and title. It didn't have any other fields. When we instantiate and save a true/false, half of the fields are going to be stored in record number 2, or for true and false, record number 3. The description, the instructions, and the points and the title are going to be stored in record number 3. But whether it's true or false is going to be stored in the other table. Same thing for the fill in the blanks. It's going to be half of the fields are going to be stored in record number 2, whereas the variables are going to be stored in the other table. Right? So if you want to retrieve the object, they need to be joined. Right? Obviously, all the joining is done for you. You don't have to do that, but it's expensive. Right? If you have to join 3, 4, 5 tables, it's very, very time consuming. You don't pay. From your source code, you don't pay for that complexity. It's all handled for you in JPA. Anyway, so the denormalized implementation is actually this is the wait a minute, where's the other one here? It's class first, right? Yeah, tape. Okay. So this is actually the default implementation. The default implementation is that right, we're going to use the single table strategy. That's the default. So we wouldn't even need the add inheritance configuration here, because that would be the default anyway. Right? This is how it would be implemented if you didn't say anything. Nevertheless, we are using table. This class is identical to the one we had before. It's identical. The only thing that I changed the name instead of joined, I called it single, right? So that I can keep track in my head. Also, the name of the table is different. Single-based question. These classes are identical to the ones we had earlier, right? So true and false is the same. The fill-in-the-blanks are the same. So from the Java's point of view, right, from Java's modeling perspective, these classes are identical. The only thing that changes is how is it going to be stored in the database. Is it going to have 3 tables? Is it going to have a single table? Right? Am I going to need to join the tables to reconstruct these instances in memory? Right? So this implementation creates a single table with a dedicated D type that allows us to keep track of what was the original class that was used to instantiate this. Right? Was it the true-false instance? Was it a fill-in-the-blanks instance? What was the type? And all the properties of all the classes are flattened into a single table. So for instance, we have is-true, variables, all that lives in a single table. For performance reasons, this is a much better solution. Right? That there's no need for joining any of the tables. Everything is stored in one single place. So basically, you are paying with space to gain time. Right? In the other implementation, you are paying with time to gain space, right? Where you would not have any empty or null values. Right? This one's going to be a much more sparse table. Right? It's going to have lots and lots of fields that are going to be null, which is fine. Right? Space is cheap. In both cases, you're not handling any of the retrieval and the storage or any of that. Right? You would be delegating this to the underlying ORM framework. So the CRUD, the repositories are identical to the ones we had before. There's no change in that. Here we are instantiating them. We're creating a base question. We're creating a fill-in-the-blank question. We're trying it out. Underneath, it looks like this. One single table, right? And notice the nulls, right? Because if it's a base question, I don't have either the variables or the is true. If it's a fill in the blanks, I have the variables, but I don't have the is true. But if it's a true and false, I don't have the variables, but I know if it is true or false. Make sense? So these nulls is a very common sight when you are dealing with denormalized schemas, right? And typically we want to avoid denormalized schemas, right? Or if we are using a denormalized schema, ideally we would not want to code it ourselves. Right? Instead, we would use a library such as JPA to handle it for us. Okay? And finally, we have the table per class strategies. Okay? We saw that both of the previous strategies have their pros and cons, right? You know, and it's a trade-off, right, of time and space, right? The table per class strategy is kind of like in between the two. Right? It borrows from both strategies. The strategy is called table per class. I created the 3 classes the same. Again, from the Java's point of view, the data modeling from Java is identical. Right? It doesn't matter how this is going to be implemented in the underlying table. So the same create table. The same Java classes, but the actual storage in the database is different. Okay, so we want to have the benefit of the normalized implementation, where we have so that when we're dealing with a particular class, we're dealing with a particular table, right? So there's a logical mapping of every class having its own table. Right? So we like that. We like the logical mapping between the two. And we really hate having to have all these nulls everywhere. Right? So we want to avoid that. So yes, we want a table, but we want to avoid having to join. We want to avoid having to join. So to deal with this, what we do, the implementation is that instead of using the single table implementation where all the derived classes, all the fields and properties of the derived classes are inherited by the parent, right, where all those fields are moved over to the parent, instead of doing that, what we do is that all the fields of the parent are copied, right, and inherited by all the children. So for instance, in the true-false, what we're going to do is that we are literally going to copy all the fields that the parent had. We're going to repeat them again here in the table for the is true and add our specific field. Right? We add our specific field. Right? If we do an insert and create an instance here, we would only insert into this table. We would not insert into our parent. Right? So there would be no need for joins. There's no need for me to join this record with the parent record to reconstruct the original object. All the information is here. Right? It's already here, right? And it's not redundant. I'm not storing in two different places. I'm storing only here. Right? So as my inheritance chain grows deeper, subsequent classes that live in lower levels of the inheritance chain will have, incrementally more fields, right? From all the fields that it has inherited from classes higher in the inheritance chain. So same thing with the fill in the blanks. We have all the fields that we inherit from our parent, right? The title, points, instructions, plus this specific variables field for this specific table. Okay. The repositories are identical. There's no difference on what the repositories do or how they work. Right? And here's examples of hitting and retrieving data. And if you want to read more about it, there's a reference here. Okay?